Welcome back to Math Teacher Institute. This is the second part in our series on preparing for the first day of a new school year. So if you haven't checked out the first part, pause this. The link is in the description. Go ahead and check out what we did preparing for the first day, because today is the fun part. It's the first day of school. What are we going to do on the first day of school? Come on in. Hi, I'm Monhar Dalal, and this is Math Teacher Institute. I've been a math teacher all over the world, and I have a master's degree from the Math for Teaching program at Harvard. If you love math and love teaching math to others, this is the place for you. All right, so on the first day of school, I like to make sure that I deliver some sort of a lesson to my students that's going to wow them, that's going to impress them, that's going to maybe make them leave my class and want to keep talking about math, at least in the hallways for a few minutes, or go to their friends and say, I have a crazy math teacher. He did this weird problem, and I was like, what? So that's what I want. That's what our goal should be, that our students leave the class thinking, this is going to be a fun math class. This is going to be an interesting math class. So I do a couple of specific proofs that students really find interesting, and I turn them into a nice class discussion. So I'm going to present them here for you as a teacher, and I would encourage you, you're welcome to take these and use them yourself, but maybe there's another area of math or another type of problem that really interests you personally and that you find very inspiring or challenging. And feel free to try something like that out, because the thing here is that you want to come across as someone who's really excited about math, who has these deep, interesting ideas about math. And that may not be the same problems that I find interesting, but that's okay as long as they're problems that are relatively appropriate for the level of your students and that you yourself actually find interesting. You don't want to have to fake it. So if you're looking for videos that you could just present to your students on these same questions, I do have some videos on the channel on these same questions in my Blow Your Mind math series. There's a link in the description below to both of the problems that I'm going to do today that are more student focused, but these will be for you as a teacher just to kind of learn from the process, and then you could present it yourself if you'd like. All right, so the first problem that I like to do is a 0.9 repeating equals 1 proof. And of course, we're not going to tell students that 0.9 repeating equals 1. We're going to let this become a discussion, a debate in the class. So I start like this, with 0.9 repeating, a space or an empty square, and 1. And I put less than, equal to, or greater than in between. And I say, okay, I want us all to vote. I want us all to vote. Which do you think is the right symbol here? Less than, equal to, greater than. So in a class of 30, I'll typically have 25 or more will say less than, and maybe 1 or 2 will say equal, and there's always a contrarian who will say greater than. So 0.9 repeating and 1, and I'll ask students if they have an opinion. Why do you think this? Why did you pick less than? Why did you pick this? The less than students, usually the answer is pretty simple. Oh, like if it's not 1, it's like a little bit less than 1, 0.00001. Okay, fine. Great. The equals, usually there'll be a couple students that have an intuition about this, but they're never that confident. And the greater than students just say, oh, because everyone else picked the other thing. Okay, fine. So then we're going to go on a little series of explorations to kind of explain this, right? We can take a few different ways of exploring this topic. I like to start with some simple ones, like 1/3 equals 0.3 repeating. And so if I multiply both sides by 3, 3 times 1/3 is 1, 3 times 0.3 repeating is 0.9 repeating, and oh my gosh, 1 equals 0.9 repeating. But of course, that's not exactly a full mathematical proof, and some students will still be skeptical, but it's a great way to start making them think like, oh, wait a second, what the heck is going on here? All right, so now that we have our students kind of thinking about this in a new way and realizing that maybe what they thought was true isn't actually true, I like to go ahead and hit them with this question, which is, if we did 1 minus 0.9 repeating, what would we get? And hands go up, and they say 0.000001. And I say, okay, how many zeros are there before that 1? And they say, infinitely many. And I say, okay, so what you're saying is there's an infinite number of zeros, and after we've written down an infinite number of zeros, then we put a 1. And they say, yeah. And I say, So after infinity, then there's the 1. Oh, I mean, that's not such a good idea, right? So now we're getting them to think about like, okay, well, yes, theoretically there's that 1 there, but if we can never reach the 1, is it really there? And then I hit them with the proof, right? So here's our proof. I start out with x equals 0.9 repeating, and we multiply both sides by 10. So 10x equals 9.9 repeating. Then we can subtract our original statement. So we subtract x on the left, we subtract 0.9 repeating on the right. So 10x minus x is 9x. 9.9 repeating minus 0.9 repeating is 9. And if 9x equals 9, then of course x equals 1. And now all I have to do is circle my initial statement, x equals 0.9 repeating, circle my final statement, x equals 1, and the answer is now obvious. If x is 0.9 repeating and x is 1, then 0.9 repeating is exactly equal to 1. And of course, this is the most convincing argument, and I usually end with this one. But it's important to make sure your students understand this is actually fully mathematically true. If you have students in a little bit higher level, maybe a pre-calc class or calculus, you could always use a proof that includes infinite geometric series. If you'd like me to make that proof for you, comment below and I'll be happy to make a video on it. But that would be only for the most advanced students. But for most of our students, they can see from this pattern and from this proof that, in fact, this is actually true. And it's a really challenging, fun, exciting debate that they can have where they learn something that most of them definitely will not know coming in. Remember, if you'd like to see me doing this proof, but directly to students, or you'd like to play a video of me doing this proof for your students, check out the link in the description below. Now we're going to go on, now that I've gotten the students kind of to think, okay, maybe some things that I would not have expected to be true can be true. Now I'm going to hit them with a false proof. And we're going to do a proof that 0 equals 1. And this is really going to blow their mind, particularly coming on the back of this proof that 0.9 repeating is equal to 1. The proof that 0 equals 1 is really going to mess with them and is going to give them something to talk about at lunch today. All right, so let's begin our false proof that 0 equals 1. Throughout this process, we want to really stress to our students that every step we're doing is mathematically correct. We want to really hype it up so that when we get to the end, they feel like, well, but I followed every step so carefully and it seems right. So really overemphasize it. So we're going to start with something simple, x equals 1. We're going to subtract 1 from both sides. So we're going to get x minus 1 equals 0. And then we're going to multiply both sides by x. So x times the quantity x minus 1 on the left, and x times 0 on the right. And of course, 0 times anything is 0, so we have x times x minus 1 equals 0. All right. Now we are going to divide both sides by x minus 1. And so on the left side, x minus 1s are going to cancel. And on the right side, we're going to have 0 divided by x minus 1. Well, 0 divided by anything is 0, right? Doesn't matter. So 0, that gives us just 0. So now we have x equals 0. But since we started with x equals 1 and we finished with x equals 0, guess what? That means that 0 equals 1. And I like to let my students simmer for a second because I finish. We just got done with this proof that they were not expecting the solution, but it's true. 0.9 repeating is equal to 1. And now I'm hitting them with 0 equals 1, and their minds are going, wait a second. There's no way this is true. But he did convince me that 0.9 repeating is equal to 1 last time, and that was true. So could this be true? And they're thinking, you can see them, they're looking at each other. And then, of course, you can let the cat out of the bag and say, well, obviously this isn't true. I like to make some ridiculous examples, like how many Lamborghinis do you have? 0? Is that the same thing as 1? No? Obviously not, right? So we know that this is not right, but now the question becomes, where is the mistake? Where is the trick to this problem? So I let students kind of debate it. Maybe sometimes a student will catch the mistake, sometimes not. Of course, the mistake is here. When we divide by x minus 1, we're not really supposed to do that because x minus 1 is actually equal to 0, as you can see. So we're dividing by 0. And of course, when you divide by 0, 0 divided by 0 is not 0. And that's really where our mistake comes. But by disguising it as x minus 1, most students will miss that mistake or miss that trick. This is something that, I would say 50% of the time a student catches and the other 50% not. But it's certainly a lot of fun, and it will give all of them something to talk about and think about as they leave your class and move on to whatever class they have next. It'll certainly make them go home thinking, my math teacher is pretty cool, and certainly is going to be an exciting year in math. Again, if you'd like to see a student-facing version of this video, make sure to check out the link below. So remember, you don't have to use both of these proofs or any of these proofs that I did for you today. These are problems that are interesting to me and exciting for me to deliver on the first day, and so that's why I chose them. You might be more into geometry, and maybe there's some interesting geometry problem that you really want to present, or maybe you are teaching a calculus class, so you want to do some weird question with continued fractions or something like that. But whatever speaks to you, whatever is something that you're passionate about and interested in, if you present that to your students, they will see your passion and they will leave your class thinking, wow, I've never had a first day of math class that felt like this. And really, that should be our goal. Don't forget also that there is a part 1 to this video where we talk about things we want to think about before the first day comes. And if you have a great first day lesson that you have presented in the past or that you're hoping to try out this year, please share it with us in the comments, like and subscribe to our channel, and maybe share this video with a colleague who might benefit from it. Thanks.